Today on Building the Open Metaverse.
It's not about skipping the artist. It's about how you enable them to do more and be more creative and provide them tools so that as they are working, you're just helping accelerate their creative process.
Welcome to Building the Open Metaverse, where technology experts discuss how the community is building the open metaverse together. Hosted by Patrick Cozy and Mark Petit.
Hello everyone and welcome back, Metaverse builders, dreamers, and pioneers. I am Mark Petit and this is my co-host Patrick Cozy.
Hey Mark, I'm doing great. We're in for a treat today.
Absolutely. You're listening to Building the Open Metaverse Season 5. This podcast is your portal into open virtual world and spatial computing. We bring you the people and the projects that are on the front lines of building the immersive internet of the future.
And today we have a special guest joining us on that mission, leading technology innovation at one of animation's most acclaimed studios. Steve May has pioneered visual effects and production tools behind Pixar classics. As Chief Technology Officer, he now spearheads development of cutting-edge pipelines with USD, or Universal Scene Description, and is leading the transformation of USD into an international standard of chair of the newly created Alliance for AO USD.
So, Steve, we like to hear from you. So, can you please tell us your journey to the metaverse in your own word?
Yeah, sure. First, thanks for having me. It's an honor to be here. I'm not sure if I'm at the metaverse yet. I feel I can see it. It's on the horizon. It's coming. My history is really about kind of like combined passion, love for both computer science, technology, and art. On the flip side, I always wanted to do both. And when I was a kid, I kind of became aware of computer graphics as it was evolving, really at some kind of very fundamental places like Lucasfilm. There was the computer division of Lucasfilm that was doing really cutting edge computer graphics. That group would later become Pixar, and it was ironic that the image I saw was a very famous image of computer graphics from 1984 that was made by Tom Porter. And it was really one of the first examples of a rendering that had things like motion blur and soft shadows and really global illumination kinds of things in rendering. And I saw that image as a teenager, and it just kind of flipped the switch for me and decided like that's what I wanted to do was computer graphics. And there was an article in a magazine called Science Magazine, and it talked about the computer division and also talked about where I went to school, which was Ohio State University. And so I kind of read that magazine article and closed it up and told my parents, like, that's what I'm going to do. I'm going to go study computer graphics at Ohio State and go maybe work for that Lucasfilm company. And it's just especially ironic for me that when I did graduate from school and I applied to Pixar, the person that interviewed me was the person who made the 1984 image in the first place, Tom Porter, who's one of the founders of Pixar and a pioneer in computer graphics. And up until the time that he retired, actually, this spring, our offices were immediately next door to each other, after all of these years later. So,
and it's been 25 years now.
I probably wouldn't have predicted that, but yes, I had my 25-year anniversary at Pixar this summer, actually, and my career has almost split in half. The first half was really working in production as one of the creative supervisors on movies like Monsters, Inc. and Finding Nemo and Cars and Up. And then the second half, really the last half, as CTO of Pixar.
How has the pace of technological change differed between the early days? It felt like there was something new every day in the 90s and now. Do you see a difference?
Everything was still being invented, and we were just still trying to figure out how you make animation at all. How do you make 90 minutes of an animated film? That was a gigantic problem when I started still, and there were fundamentally unsolved problems, and so it was just constantly like an awesome struggle and challenge to figure out like, how do we animate, fur? I worked on Sullivan's fur technology for Monsters Inc. and making Sullivan for that film. And we had just never animated fur before, and in fact, really haven't been done anywhere before that. So we had to write the software to do the grooming for the fur and the dynamic simulation for the fur. We didn't know how to shade fur, make it look like hair. So we had to figure that out. RenderMan, we didn't have good ways to even calculate shadows for hair. So we invented deep shadows, which then led to things like deep compositing, but that we didn't even have a good way to create shadows. So we were really figuring out just fundamental stuff. It was kind of the same. The next film I worked on was Finding Nemo. We really didn't know how to animate water. We just used whatever technique we could. Simulations took, days and days to run, and they were not very good. I still kind of have to cover my eyes when I watch certain scenes in Nemo because it's so crude and simplistic compared to what we can do today. It's remarkable. I mean, water is still hard, still expensive in visual effects and animation today, but what can be done is mind blowing compared to what we did back on Finding Nemo. And one of the other things that's really interesting is just kind of the composition of the people that are making the movies here. When I started, really most of the artists here, we generally refer to them as our technical directors. Most of them had to do some amount of programming to get their job done. Some of them a lot of programming to do the job, even to assign the material to a model. That required writing code, back when I started at Pixar. And so another thing that's really changed a lot is that, we've evolved from where most of the artists at least did some programming or WordPress programmers and writing the tools as we went. So today we're really, that's the exception. Most of our artists are really excellent, amazing visual artists. They're obviously good at using computers, but they're not writing code. The software is much, much more sophisticated. And so the kinds of technology we do today are much like bigger things like Presto, which is our animation tool, or USD. RenderMan continues to evolve, but they're like these big, significant, very highly engineered software projects. And the expectations of the users is that those products and those things work very, very well. They have very high expectations for very streamlined workflows and very, very solid, reliable software. Whereas when, 25 years ago, the expectation was that it probably wasn't going to work. It would crash all the time. And you probably would have to write some code yourself in order to get your job done. So it's changed quite a bit. And I would say the level of innovation in some ways is just as high, but it's more at these kind of large impact, big software project level.
So when you look back, is there a moment or a milestone that, you look back as being, transformative or a turning point?
It's hard to single out single things. I mean, compositing. I mentioned Tom Porter, who I worked with on Monsters, Inc., and I interviewed with at Pixar. He invented compositing. I mean, that is such a ubiquitous technology that every person on the planet, uses today. Because if you use a phone, it is compositing graphics layers on top of each other. So there were just fundamental things like that, like developing RenderMan so that you had depth of field, motion blur, things that you would expect to see in a live action film so that you could then integrate graphics into live action films in a meaningful way. And then more recently, there's just been so many things since I started. When I started, like subdivision surfaces were really becoming I think we used at Pixar, and that was a very fundamental technology. Path tracing, really the last 15 years or so, that fundamentally changed the way that we work. It fundamentally changed the scale of our data centers. Our render farms are much, much bigger than they used to be, largely to support path tracing. But that has enabled us to do things that we couldn't do before too. Like we really run dailies. We can now render the entire film or entire chunks of the film overnight or over the weekend and review shots in complete context, so that when you're looking at even in progress animation or in progress effects animation or camera work or other things, you can see it in full context with lighting and everything else in the scene. And we didn't have that before path tracing and really big render farms. And that really kind of changes the way you work, because the artists are always looking at things in context. So there's been just a number of fundamental changes. There's also been things like the GPU that has changed the way that we work in terms of interactive tools, but also the way we render things. And RenderMan's gone through multiple evolutions. RenderMan's been around since 1988 as our rendering tool, and it's now in kind of third major iteration, which now really leverages the GPU to do things. So there's just been so many things.
And in Elemental, you pioneered volumetric rendering too.
I get the question of like, well, what's still left to figure out and do in computer animation, computer graphics? I'm like, oh, we're just getting started. Like we're still scratching the surface. We're still like struggling with really hard problems. Elemental was one of the hardest technically and in some ways artistically, one of the hardest movies we've ever made, because each character is a true volumetric render and simulation. So in Elemental, we have characters that are made out of fire and water, air and earth, and in particular, the water, air, and fire characters. These are volumetric simulations that are computed dynamically on every frame and then rendered as volumes. And the amount of storage you need to store all that volumetric data, you can imagine a scene where you've got a crowd of characters that are volumes. And then the computation required to render those volumes is extreme. We had to really rebuild our data center to kind of support making that film. And artistically, it was super challenging too. Like, how do you, reading the facial expressions on a character that is an evolving volumetric fire, but you need to have appeal. The character needs to be appealing. You need to be able to see the eyes and the mouth shapes, and you need to be able to animate very expressive poses so that you really can connect with the audience. That's an extreme artistic challenge too. So I love that, like, even today, after all these years, we have films like Elemental that really kind of push the envelope as far as what's possible and what we think we can do.
I mean, when you look at making a film today, how are you balancing supporting the production needs versus those longer term R&D initiatives?
It's a challenge. I mean, one of the things I would say that is unique and awesome about being a technologist or software developer at Pixar is that you make really like state-of-the-art software for a very small number of like a few hundred of the best animators, in the world. And you're not making software for thousands or millions or billions of people. You're making it for a few hundred. They're the very best at what they do. And by the way, their office is right next door. So you will hear about it if the software is not great, but also like that ability to sit next to an animator and learn how they do what they do, and then kind of in real time work with them to solve problems and evolve the technology is super special. But the downside is that connection that's amazing does make it hard to carve out projects that are not being driven by the active productions, the active films we're trying to create. So we just we do balance it. We mostly, we're a movie studio. Our job is to make the film. So we mostly will drive things based on what the movies need. But then, for example, like we mentioned, USD, Universal Scene Description, that is a project that we carved out because we identified that as a long-term problem that we wanted to solve within the studio. The movies were not asking for that at all. I had to cajole the first show to use it, to kind of take it, because that was not driven by them, but it was a priority for us at a studio level. And so I guess the answer is we just try to build that into our project planning, and it's really, really hard, but it's also the fact that it's hard is what makes it so much fun to develop technology at a movie studio.
How has your technical team evolved over the past years? I mean, do you recruit differently? What's the kind of profile and that you're after?
There was a time when I probably could have been a developer in our software teams. I did have a software engineering, education, and did write a fair amount of software. But the level of sophistication of our software engineers is so much higher than it used to be. Writing a GPU-based path tracer in today's world, for major animated feature film or visual effects production, like the Render Man, requires a very high level of skill, knowledge of computer graphics and software engineering ability. And we see that not just obviously in Render Man, but in our animation system, in Presto, in USD. And so I'm blown away by the skill level of the software engineers that we have. I think that's the biggest change. Otherwise, I think in many ways things are similar, and especially in the way that we try to make sure that engineering and animation production are really close with each other.
Steve, I want to ask you a bit about the leadership and culture side of the house. So as you know, last season we had Pixar co-founder Ed Catmull on the podcast. And we love his book, Creativity Inc. So actually at Cesium, every new person who joins, we give them a copy of Creativity Inc. We say, hey, this is kind of how we aspire to act. So could you tell us about leadership and culture nowadays at Pixar?
We refer to that book often here still. And Ed still stops by on a fairly regular basis. And if he does, there's a line of people willing to ask him questions and get his input. And the thing about the culture of Pixar and Pixar is over 40 years old as an entity. So that the culture we have today is the accumulation and the result of many, many years and decades of the things that people like Ed really brought. And things change. They always change and evolve. All companies are living organisms. They have to modify the way that we do things. But when it comes to, a lot of the things that, Ed was really formational about here, we carry that on in not only in his honor, but because it's really the smart thing to do. We have Ed's background in academia, and I have some of that too. We really put an emphasis on research. We put an emphasis on publishing papers, presenting our research, sharing technology through open source projects, all those things when it makes sense, because we believe that if we have that sharing, and I would say one of the great things about our community in general and in the film industry and visual effects and computer graphics and animation is that we are a collaborative community. Even though it's a competitive space, we're collaborative. We realize that if we share things, especially things that are kind of baseline technologies, that we can all benefit from each other's developments. We feel like if we publish a paper and then 10 students read that paper and then they write 10 papers, and then that will come back to us and benefit the studio. I think that you can see that in many different ways. And I think that's still like a fundamental principle that we go by.
You and I were on a panel at SIGGRAPH talking about AI. So we have to touch on the sujet du jour. So are there any specific capabilities that gets you really exciting to deploy in production over the next few years?
What I think is going to be exciting is like the prompt-based stuff is great and it's amazing, and there is an important place for that as we go forward. But I think the way that we'll really manifest it is we call it artist in the loop, which is it's not about like skipping the artist. It's about how you enable them to do more and be more creative and provide them tools so that as they are working, you're just helping accelerate their creative process. It's not about doing something where we can just bypass the creative process or bypass that artist, the talented artist that we have. The other thing is that we are very, very, very specific about how we animate things. So, the shape of the profile of a character silhouette is something that we fine tune within we would call like a pencil's width, mix that kind of adjustments. And I think where we are not at with most of the AI techniques is in that level of directability or control. And that's what we would have to have in order to use it to do most of the things that we do. But what I'm hoping is that we still do a lot of things that are very tedious and time consuming and probably are actually not that much fun for the artist. And so again, if we can create those tools that where the artist is in the loop and you're just helping them accelerate and skip over the parts that are more tedious, provide more inference and suggestions for what they might want to do next, rather than just having them manually specify every single thing, I think that's where there's a ton of potential. We do one of the benefits of Pixar. We've got this great culture of innovation, but also we work within this bigger company, Disney. We very closely collaborate and share technology and learnings with the other studios within Disney, like ILM and Disney Animation and Marvel, but also Disney Research. And there's a lot of interesting experiments. But one example is when you're posing a character, what we generally do is we have thousands of controls for every character, literally thousands and thousands of controls for each animated character. And most of those controls, they are hierarchical, so they're higher level controls, like a pucker control for your mouth, for your lips on an animated character to make like a boo sound. But a lot of times it's individual controls. And so, one of the things that we're kind of looking at is based on our existing set of poses that we know about in our training of all the data that we've got here, because we've got the data from all of our films all the way back to Toy Story. It's still online and accessible all the time here at Pixar. Can we do a better idea or a better job of guessing that if someone moves an elbow joint, would the hand likely follow it instead of them having to move the elbow and then move the hand?
So it's about augmentation and acceleration.
It really is. I haven't seen anything yet where I'm like, oh wow, that just kind of, you could do that instead of having an artist do it. I don't see that happening anytime soon, nor do I really want that. I don't want a kind of world where that happens, I think. And the creativity we get comes from the spontaneity of the artists as they work. We often don't know what we want until we start working on it. And in the process of working on it and making it, then we kind of realize what we're doing. And that's what creativity is.
Steve, you also mentioned Disney. So Pixar recently announced it's working on its first long-form animated series for Disney+. I was curious if you could share a bit about how your approach to the series would differ compared to feature films.
So the pipeline is essentially the same. We're not changing software. We still use Presto and USD and RenderMan and our other tools, and also commercial tools like Houdini and Katana and Maya and other things that we use. The thought process is different. So with the series, we've got more footage. We got more minutes of animation to produce, and the economics of streaming series are such that we are trying to do that with basically a smaller budget per minute. So really, the main thing is just kind of is being creative about how we think about solving the storytelling problems in streaming, and how we alter kind of our mindset about features, because we demand the same kind of quality of those streaming series that we had demanded of one of our feature films. So what's been really inspiring and great about it is that kind of shakeup of, hey, you need to kind of make more footage for less and get the same kind of quality, is it really makes you rethink the way you do things. So it's been more about like how we modify our process, how we run our creative reviews, how we just kind of it's been kind of freeing to say like, hey, we don't want you to do things the way you do them for a feature film. Think about different ways to do it for the streaming series. And then one of the great benefits is that then those new learnings and thoughts can now flow back into the way we make feature animated films, so that we can make our feature animated films even better too.
I remember also you talking about a new medium like AR, VR, and mentioning that, just to figure out what immersive storytelling really means. So what have you learned so far with those new mediums?
Our job is still to make movies and streaming content, linear content. But we have done experiments with immersive kinds of storytelling. And I would say what we still know today is that it's really hard to make really, really compelling stories in a way that can connect with the audience at an emotional level that our films do. And that's not to say that it's not possible. Like, I think that will happen. I think it's just still a new medium. We're still figuring it out. It took us a long time to figure out how to do that with movies too. And the potential, I think, especially for Pixar and for Disney is really compelling. Fans of our movies and fans of Disney content in general, they're really big fans, and they really want to continue after they've watched the movie. They want to kind of continue to connect with the stories and connect with the worlds and connect with the characters. And you kind of see this in the devotion to the things like the theme parks, things like consumer products, even Disney theatrical, the stage plays and musicals that Disney does. So it feels like it is such an opportunity for a company like Disney and studios like Pixar to continue to engage with the audience, after they've seen the movie and in a completely different way. And I don't know really any company that could do that better, because we already have immersive things that are called the theme parks. So like Disney really kind of knows how to do this. We have these great stories. We have this great legacy of characters and worlds. And so like it just seems like the obvious thing is the next step is to bring in like interactive 3D immersive content and connect all those things together in a way that I think would be really fun for audiences, and would make a lot of sense for the company. But it's early days, and we're kind of figuring that stuff out. But I think the potential is super exciting.
I think I saw Bob Iger on stage at the launch of the Apple Vision Pro. Everybody did. I was actually the only outside person from Apple present at that announcement. So do you think that device, or maybe not the first one, but this kind of device has the potential to be transformative?
That device is very impressive technologically, and Apple has a track record of making platforms that gain wide adoption by audiences. So I think all of us that are interested in immersive content are I think optimistic and hopeful that, again, we're moving along this path to where we can really have that kind of content be more available to a broader audience. When I kind of, since we're talking about the metaverse in this podcast, and I think about the metaverse is really about like getting 3D content, either creation or consumption, beyond the walls of computer graphics experts and people that do effects and animation and gaming, and into, like, I would say, regular people's hands, in air quotes, like our friends, our family, people who all don't nerd out on the same stuff that we do. That's what it's about. And so I feels like we're on that path. And the things that were shown in that keynote were very exciting, both from Apple, but also the ideas of the things that were shown in the part with Disney, I think, kind of give a window to what look like.
Steve, I wanted to ask you about Realtime in general, right? So you talked about all the advancements to production and GPU path tracing. How do you see a Realtime 3D, in a complex pipeline like Pixar's?
Two sides of this. In one way, is like we're like the opposite of Realtime because we still make we make movies and we make streaming content, and that's basically a recorded format, right? So even though it plays back at 24 frames per second or 30 frames a second, or we could take as long as we want to make each one of those frames because it's recorded. And our renders today, it sounds ridiculous, but a single frame of one of our films can take tens of hours, sometimes hundreds of hours per frame to compute the final quality. There were frames in Elemental that took hundreds of hours per frame to compute. So on one hand, that's like we're like the opposite of Realtime. On the other hand, that's how we want our artists to work. Artists you don't want to wait for a result. You want everything to be interactive. Most of our pipeline has is very interactive, or you could call it real time. There's still aspects of art. In general, rendering those final quality images is clearly not interactive, although we're working on that really hard with Render Managed View and making some big strides there. So things like lighting are still not real time. Some forms of simulation, like complex cloth simulation, are not real time. But we work really hard to make advances and innovations so that the feedback to the artist is as interactive and real time as possible, because that just, again, it's just another way to enable more creativity, make a better creative process. I always, when I try to, it's hard to even explain to some people who haven't used simulation software or complex lighting software to understand that you have to wait to see the results of your change. So I've equated it to, like, imagine like you're playing like a guitar and you strum a chord, but you don't hear what it sounds like for a couple of minutes. And then you have to like say, oh, okay, that's not what I want. I'm going to change it. And you strum another chord, and now you have to wait again a couple of minutes to see the results. And clearly that's not ideal. So we're working really hard. We talked a little bit about AI, besides things like generative AI that actually can produce some kinds of content, machine learning in general has really opened up a lot of things for making much, much faster renderers and much, much faster simulations, character rigs, and other things like that. And so we're really seeing benefits from that already in significant ways that give us much, much faster real-time feedback for our artists and animators.
Well, let's switch gear a little bit and talk about another topic. So Pixar has a very long tradition of contributing and even releasing open source software, OpenSubdiv, USD, of course. I think did you initiate Open Timeline IO as well?
You could actually, technically, you could go back to the RenderMan interface specification, which was published in the 1980s, because that was really an open, did not necessarily succeed as a very broadly adopted standard, but it was an openly published standard. But in the modern time, yeah, OpenSubdiv was the first, and Open Timeline IO is our most recent open source project.
So how do you determine what needs to remain proprietary versus what gains from being shared?
We have a variety. We have a range of technologies here. And RenderMan is a commercial product. USD and OpenSubdiv and Open Timeline IO are open source projects. There are even some things that we might keep as just proprietary trade secrets, et cetera. I think the approach that I take is to look at each technology, and we think, what is the best way to use this for the most benefit to the company, and that's what determines how we apply it. So, in some cases, the best route with the technology is to publish a paper on it, because we think that'll give us the most benefit back. Like I mentioned earlier, like students read that paper, they do research, and then that can come back to us as a benefit. In other cases, it is to keep something proprietary, and in other cases, the benefit is to open source, and that's really just based on like what will give us the most strategic value. The subdivision surface technology is an interesting case study, because that was our first one, and we created the subdivs for short. We created that technology. Actually, Ed pioneered that with Jim Clark, originally in the 1970s, but it wasn't until really the 1990s that we kind of came up with a more practical formulation of it. And papers were published. Tony DeRose published an excellent a paper on it. We found that even with that paper and all of the detail that was in it, it was hard for others to implement it exactly correctly and to match the way that we used it internally at Pixar. So it would be great because it would be adopted and someone had incorporated it into some software that we would use, but it'd be slightly different than our answer internally, or what RenderMan would produce. And if you rendered the same mesh, and we realized that we weren't really getting the full benefit of the technology. What we wanted was all the other software that we buy that's commercially available to do it exactly the way we wanted to do it, so we would match our internal software. And the best way to do that was to provide a reference implementation. So if we made an open source version that was available to everyone, they wouldn't have to guess about the math of the implementation details. They could just take that reference implementation, they could incorporate it into their software, and then it would work the way kind of we want it to work. Everything would match between different software applications, whether they were external ones or internal ones. And that was where we would get the most benefit from the technology. And so that's why we open sourced it.
So before we talk about USD, in the spectrum of open source versus commercial like RenderMan, where do you think this Presto belongs?
Okay, so first of all, USD, USD is a lot of Presto is in USD. And so especially as we continue to expand the capabilities of USD, effectively more and more of Presto is basically it's open source because it is in USD. I wouldn't say it can happen. It won't happen. The question does come up about Presto and things like even things like RenderMan, but there's no plans to open source either one of them.
Earlier, you mentioned that when you think of the metaverse, it's going to enable everyone to do 3D creation and 3D consumption. And I guess, if you look forward 5 or 10 years, is there anything else you'd want to add to that creative metaverse vision? And then how you think USD and other technologies could enable this?
Obviously, we're big believers in USD. And I do think that could become the common currency, as you were, of the metaverse, right? That is the way that we will exchange 3D content as we go forward. I think from it's such a broad potential set of applications that we talk about when we talk about 3D content and in the future. It's a little bit hard to put a pin in the bigger concept and impact. I think from a Pixar standpoint, I think more about the potential for storytelling and connecting with audiences, and that really means, making it something that is accessible, and things like USD and open standards are key to that, but accessible to a wide audience. You're making it accessible to a wider audience of creators, and I think whether those creators are within Disney or Pixar or elsewhere, we'll figure out really exciting ways to use immersive 3D content as a storytelling medium. We'll start to really figure it out.
USD is being used for real-time and many interactive applications. Did you ever expect that? I mean, you've done a good job telling us you guys do movies, you focus on making movies, and now we see USD at the heart of real-time platforms. So, what does it mean for you guys? We
expected it would get, USD would be successful and within the film industry. We feel pretty confident about that, including for, I mentioned before even that our tools, we have a lot of interactive tools that leverage USD in-house. Even our animation system can run in real time if you simplify the scene enough. But I really did not anticipate it going kind of beyond the film industry. That's been a really pleasant, exciting surprise, is to see the interest and adoption in industrial applications, in areas that, I think, Mark, we did a panel last year, where we had really people from completely different companies and industry, including car manufacturers and home retail hardware stores. And it's like, yeah, exactly. It's like, wow, we did not anticipate that. And that's super exciting. I think there's some fear like that could fragment or dilute, our use of it for film. I think that's a reasonable thing to be worried about. But I think on the optimistic view, I look at how all those other interesting worlds and applications and industries could feed back very interesting technology back into us. Computer graphics has a long treasured history of adopting science and technology from other fields and incorporating them into the ways that we do computer animation. For example, like dynamics and simulation is a prime example, but also just rendering and pulling from fields like optics and other areas. And so I see that as just an enormous opportunity that other companies will think of ways to use USD that we never envisioned, and that will benefit us. I feel like it feels like a real honor and validation of a technology when it gets used in ways that you didn't anticipate. And I think that's so satisfying to see it being used in ways that we never really would have guessed.
One of the magical parts of USD is enabling that collaboration at scale. Could you tell us a bit about how it works?
There's multiple, I guess, axes of how it enables collaboration. I mean, one aspect is just there's been a great focus by the engineering team on performance and making sure, for example, that you can load and manipulate and edit very complex scenes very, very quickly and interactively. But so that's one aspect. But I would say the biggest aspect is the way that it basically allows you to aggregate and assemble scenes from a collection of individual USD assets. So at Pixar, we have many people working on a given shot in a given scene at the same time. And what it allows you to do is USD allows you to kind of compartmentalize the work into layers. And in the same way that when you edit one layer in an image editing software like Photoshop, you're not breaking the other layers. That's kind of how we think about animation and building our films here, is that we have artists working in different USD layers, and they can do their work. But at the same time, you can see what the complete scene looks like by compositing all those layers together and seeing them and seeing them in context. And that's really, I think, the key for collaboration, is the way that from the very get-go, because USD is based on technology that we've been using to make movies for many decades, preceding the creation of USD. And that was all about how do you let a lot of artists work on the same content together and build very, very complex worlds and 3D scenes. And I think that the most fundamental part of that is the ability to layer and then also, reference or pull in other models to make one aggregate scene from a bunch of individual parts. It's the ultimate divide and conquer. If you're making a very, very complex scene, you don't have to think about it as one entity. You can break it up into individual small pieces, and those small pieces can all be edited, manipulated, and created by individual artists and then combined together in a very efficient way.
You are the chairman and co-founder of the Alliance for OpenUSD, which was created a few weeks ago. So tell us about the charter of the organization and your goals.
The goal is to evolve, so USD is on this path. I think we've talked about like the impact, and it could become it will become, I think, the currency of 3D content going forward. The next step on the path, the open source project, we open sourced in 2016. So it's been available for quite a while. It's been in use at Pixar since the Finding Dory fell, was the first movie we used on here. Along this path of developing it, using it, open sourcing it, getting industry adoption from it, the next step is really try to make it into an international standard, a formal international standard. That's really the core goal of the Alliance, is to evolve USD into an international standard so it can become that currency we all kind of hope that it will be and that we need for interchanging 3D data in the future. So it's pretty simple. That's what it's about.
Have you guys started to work on that?
The core working group, which it's specifically, its charter is creating the specification, is just getting up and running. So exciting things to come.
And Steve, are there any just parts of the roadmap or ways that you're hoping that new partners will help contribute and evolve USD?
Applications in like architecture, construction, industrial applications. Those are ones that are very interesting and not Pixar's expertise. So I'm looking forward to just seeing the things that come from those other areas. That would also include, I should also add to that, like interactive components that you would be interested in for immersive stuff or games. Internally, though, even at Pixar, we still have a lot of things that we want to contribute back into USD, including animation curves, including things like rigging for characters, which, by the way, also requires having some sort of execution system. So we're very busy right now on both the animation curves and the execution system to kind of lay the foundation for really kind of the next generation of the kinds of content you can make in USD, in particular as far as like animated characters, avatars, and that kind of content.
Steve, I wanted to ask you one last topic. So you were talking about all the papers that Pixar has been publishing, how that's great that students get a hold of them and do additional work. Also, I'm sure an amazing recruiting tool. As you know, I used to teach in the graphics program at University of Pennsylvania, and many of our students have went to Pixar. I'm doing everything I can in the Philadelphia area to help build, a graphics presence with all the other universities. Do you have any asks for things that you think you'd like to see in graphics programs at university level?
Well, first of all, thank you. Penn's been a great source of talent for Pixar over the years. I think the thing that I always, if I talk to people at different universities or colleges, is finding ways to interject the art and technology together. So if you're a computer science professor, find ways to connect with the College of the Arts at the university, or to bring in students from other areas. Not even traditional art, but it could be music, it could be drama, could be other forms of art like that. I still feel like that's where the magic, sauce is Steve Jobs, the founder, original CEO of Pixar, was big on that intersection of technology and art, liberal arts, and that's where I think there's just an enormous amount of potential there as we go forward, especially as technology becomes more sophisticated and more advanced. It feels like it's increasing at an ever greater rate. Having the sensibilities of liberal arts and artists involved with that, I think, is really important to us as a society. But selfishly, as a person who works at Pixar, computer science students, computer graphics students that have sensibilities around art, that's still the secret thing we're always looking for.
Thank you, Steve. Well, take us to the last question of this podcast, which is our traditional ask. If you have a shout out that you want to make today to a person, an organization, an institution, or a company.
I'm going to keep it simple. I'm just going to give the shout out to the software engineers we have at Pixar, both in our tools department. We really have two main groups: tools and RenderMan. They are the best. They're world class. They work extremely hard. And since we're talking about the things we talked about with USD, the USD team is amazing. We've been growing that team a bit to handle all the new things we want to do with USD, and we've got great leadership there. Sebastian Gracia, we all call Spiff, and Florian Zitzelberger. There are two leads of that project. They're doing an amazing job, and so I just give a shout out to everyone at Tools that develops software and works with our software teams.
But I would add a shout out to Nick Porcino, because Patrick and I are at the Metaverse Standard Forum, and he has been such a positive force to bring people together and to drive that interoperability. And honestly, we owe him a lot in terms of the progress we're making, aligning GLTF and USD. So Nick Porcino is a rock star. So thank you for letting him spend time with us.
But I do want to say that, in addition to Nick, we have just this amazing engineering team in general with USD that does all the behind the scenes work. So just the huge credit to all of them for the work they do. They're the ones that actually make this happen. So,
well, Steve, it was an honor to learn about your pioneering work at Pixar of using technology and storytelling. We're truly inspired by your approach, crafting custom tools, commercial tools, open source projects to enable the magic of filmmaking. And your passion for blending engineering and creativity is really, truly remarkable. So it's remarkable to see you lead the creation of a standard that might be the foundation of the immersive and spatial internet of the future. That open metaverse that we all talk about. So, fantastic job. Thank you very much for being with us today, and Godspeed.
Thanks for having me. It was a pleasure.
Thank you as well to our ever-growing audience. And you can find us on our LinkedIn page, of course, on major podcast platforms and on YouTube, as well on our own buildingtheopenmetaverse.org website. We'll be back soon for another episode of Building the Open Metaverse.